Hey, what is up guys? Welcome back to another video, and in this video we are going to be continuing on with our Swift programming tutorial series. And in this video, before we move on to learn about classes and structures in Swift, I need to talk to you guys about what the difference is between heap and stack memory, as well as the difference between reference and value types. Those concepts go hand in hand, and they're very, very important for you to understand exactly how your code works, exactly how the Swift compiler goes and counts your references for classes and all kinds of other stuff. But the most important part, and probably the most common thing you'll hear about, is performance. Performance is highly dependent on your efficient usage of memory, and understanding how the stack and the heap work will go a long way in allowing you to enhance the performance of your applications of your code. So, let's first talk about what stack and heap memory are. Well, the stack is faster, more efficient memory, although the stack is very limited in the amount of memory you can use. Think of stack memory like a stack of plates or a stack of bowls in your kitchen cabinet. You can very easily go in, quickly grab a plate or a bowl, use it, and then clean it and put it right back in. Right? It's very fast, very quick. Whereas the heap you can think of as like your kitchen counter when you're cooking. You have a lot of stuff spread out on your counter, and because of all that stuff being around, it might be a little bit slower, a little bit harder for you to move stuff around, to find something on the counter, put a new thing on it, stuff like that. It's going to take a little bit slower, right? Well, that's how the heap works. The heap is slower. It's a larger memory space, but it's much slower to allocate memory to the heap and to search the heap for memory and stuff like that. So, when we're talking about stack memory, value types such as variables, parameters, and return values are stored in the stack. Whereas when we're talking about something like a class or a function, those are reference types, so they are stored in the heap. And the reason why functions and classes are stored in the heap is because you want those around for a very long time. You want those to persist throughout your program, whereas variables are on the stack because you don't want variables and their values to stay around forever. Okay? So that's stack and heap. Now, what is reference types and what are value types? Well, value types are stored on the stack. They are things that contain little bits of memory. They're not very large, generally speaking. They're very quick to access. And when it comes to a value type, the data you store in, say, a variable or a function parameter, that is stored directly. Whereas with a reference type, any data you assign to an instance of a reference type, the address of that data in memory is stored, not the data itself. With value types, when you pass them around, or when you assign them to a new instance of a value type, the data is copied. Not a reference to it, like with a reference type, but all the data is copied. So if you have a value type, such as a structure, with large amounts of data, you can see how copying large amounts of data every time you need to pass it around can be very inefficient, very ineffective. That's why when you're passing large amounts of data around your application, you're going to want to use a reference type such as a class. So that way, the reference to the original instance of that reference type gets passed around. Much more efficient than copying every single bit of data into another memory address. Right. So that is pretty much the difference between reference and value types and how they interact with stack and heap memory. There's not very many differences, but they are very fundamental differences, and it's very important to understand before we actually talk about classes and structures in earnest. So thank you all so very much for watching, and we'll see you in the next one.